Okay, so we have one more example to talk about in section 4.3. The scatter plot shows the association between age of a car in years and the value of a car in dollars for a small sample of students. So I'm going to uncover this and we can see what do we know from looking at our scatter plot. Okay. We can see that the scatter plot shows a relatively strong negative linear trend. Right? Our line is pointing downward, so we have a negative linear trend here. Right? And then as far as our interpretation goes, we're going to talk about what happens with our x and what happens with our y. So the data suggests that the value of a car tends to decrease as it gets older. Right? As our age, our x increases, y decreases, our value decreases. Right? So that's what we know about our scatter plot just by taking a quick glance at it. We don't even need the equation that's listed at the top, but we will use this equation in the next couple of parts. Right? Can we predict the value of a 10-year-old car in this sample? Yes, we can. We're going to plug 10 into that formula that we see up at the top of our scatter plot there again. Right? So our predicted value is going to be 21,375 minus 1,215 times 10, because our value that we're looking at is 10. We plug this into a calculator, we get 9,225. So a 10-year-old car in the sample tends to have a value of $9,225. Right, then the last thing we have to finish off is we're going to talk about our slope and our y-intercept. So our slope, remember, is the number that is connected to our x variable, our independent variable. So our slope in this case is the negative 1,215 that's connected to our age variable. Right, so the slope tells us that for every additional year the car ages, so for every time x increases by 1, the value of the car tends to decrease by $1,215. And it's decreasing in this case because our line is pointing downward. Right? So as x increases, y decreases. Right? The cost of the car is going down. We have a negative slope. Right? We had a negative positive linear, or we had, excuse me, not a negative positive. We had a negative linear trend. Right? And then the last piece, the y-intercept. The y-intercept tells us that a brand new car, a car with an age of 0, tends to have a value of $21,375. So in this sample, a brand new car would have a value of our y-intercept. Our y-intercept was at 21,375. So this is something that could potentially be useful in this situation. Right? Down at the bottom of this page, just kind of one more little hint. If you're trying to think about and write out these sentences, one way you can phrase your sentences, again, it doesn't really matter. For every one additional x, whatever that is, y tends to increase or decrease, whatever the case may be, by what? And then for our y-intercept, if x equals 0, so if it's a brand new car, if they've hit 0 home runs, then what happens with y? What is that value? So as we're going through this section, as we're going through this chapter, as we're going through chapters in the future, a lot of our answers are going to be not just the numerical things that we're calculating, but we do want to be able to explain the interpretations of these different values and different things that we are seeing as well.